Okay, so I'm so delighted Professor Biplav Srivastava has joined us to give uh, earlier we had intended for him to join us in person, but something has come up and that was unplanned, and so he has to take this seminar remotely. Of course, you can find him, his office is just around the corner here, should you ever want to meet him. Now, with Dr. Srivastava brings a very rich experience. He was at IBM Research for about 20 years. He has some huge number of patents. I don't even remember how many, but maybe 50 plus, 55 or something. And so clearly a very, highly tied to a whole variety of innovations. Um, and Here he leads a group where, one of the key topic is planning and LLM. So the topic that he's going to talk about is the one that he and his group have been very active in publishing in some of the top conferences. Vishal Panigani, who is a PhD student here, is co-advised by him and me. And due to Dr. Srivastava's contact, he has been doing internship at IBM Research, working on also this particular topic for some time. So this should be, it's a very active area of AI also at this point of time. So there should be a lot to learn from today. Over to you, Biplav.
Yeah, thanks, Amit, for inviting me. And sorry, class, I could not be there in person. Very much wanted to. So here is the plan for today. I'll give you a little brief on what planning is and the setup here. Then the motivation for why LLM may want to be used in this particular situation, in this problem domain. And frankly, the answer is that no one knows. And then in this area, we'll look at some of the opportunities of how LLMs may be able to help planning. And then two ideas that we are pushing for. One of them is to design a LLM from scratch for these kind of tasks. And second is to use any LLM as a one solver in a multi-agent architecture for fast and slow solving. So I'll explain that and conclude. Okay. You can ask me questions at any time. I will be able to paste the things accordingly. Okay, I should mention that a lot of the work is by the students that was mentioned earlier. Okay, so what is planning? It is a form of decision making. It's a complex decision making. Normally, if there is a single decision to be made, you look at what is the benefit, what is the cost. You might do benefit minus cost and do it. Planning is a form of a sequential decision making where there is an agent which is working in the environment and they have some goals and they are perceiving the environment, they are taking actions, then they are observing what has happened and repeating the cycle. This is a very active area. It's a long-term area in AI. And there are some complications. So the complications are that whether the environment is changing or not, whether it is observable or not, whether your actions are deterministic, whether they have durations or not, whether your perception is perfect, and do you want all goals to be satisfied or some of the goals to be satisfied. Okay. A simple example of planning is you trying to drive towards going to the airport. So, well, it is not just about the plan generation, but there is a supporting life cycle. So here what is being shown from left to right is typically a planning problem. You give input. Depending on your representation, you might give just the data instances, or you might give something called a domain file and a problem file. Domain means I'm trying to solve blocks world or driving and those kind of problems. And specific problem is called a problem, right? So the planner generates a plan, it might be stored somewhere, and it may be executed. And then later on, when you get a similar problem, you may want to do the same planning from scratch, or you may want to retrieve something from your memory, and act accordingly. So for example, when we are driving every day, we don't think about the same path, we just retrieve it perhaps and take that plan. So it's important to think about planning not just as plan generation, but also as a plan lifecycle problem. Okay. So a very simple, trivial example is that you have two blocks on the table. You have two robotic arms, and you want to make a block 8 on top of block B. So how do we solve it? We represent this problem, and this is the model-based approach, where there are actions which are represented to specify the state transition. What is the condition state before? What is the state afterwards? And only what the robot makes the changes are the only changes which are made, right? And if you can do that, then you can actually create what is called a search space. And so a simple way of solving this is like a search space. These are the possible actions from the very beginning. These are the things which cannot be done, which are marked in red. And from the various conditions which are possible, what you are doing is you are looking at, just a minute. So a lot of these animations are out here, but you wanted to put A on top of B. Two ways of you can use a robotic arm R1 or R2 to do that. And once you have set up the search space, what you're doing is you're going to be doing a search backwards to find the plan. Okay, so this is very much like a A-star search, which you are doing, and this is a compact representation of a very simple planning problem. Of course, we have more complicated plans and more complicated problems. So in the case of blocks world, this is one kind of configuration you want, and these are some sequence of actions to achieve them. Okay. All right. So as I mentioned, this is an active area of research. There are a number of considerations which make this problem simple or easy. I already told you what is the complication of the problem, but what type of plan do you want? Any workable plan versus you want an optimal plan versus you want all plans that are possible, all minimal plans. Do you want all different plans? So one of the ways to look at this is, suppose I want to figure out what are the different ways to attack my system to improve its security. I might be looking for different ways people can attack my system. So that's the motivation for diverse plans. Okay. Then when to find the plan, which is at the end of the problem versus you are trying to plan anytime and you are solving. Okay, Ritvik, is there a problem?
We just had a little bit of internet trouble. It's all sorted now. You can continue.
Okay, sure.
Thank you.
Yeah. So when to find the plan, it might be you find the plan, then you execute it. Sometimes you cannot do this. You actually do interspersion of plan and execution. Okay. And how do you represent the plan? It can be in a formal language like the PDDL I told you, a planning domain description language. A common method to solve that is through search. Another area is you might just be given the traces, the data, and you are told, okay, go and find the plans. This is a typical domain of reinforcement learning. And you might even be just told as a natural language, okay, I want to go to the airport. Tell me some way of doing it. Okay. And even if it's not there, maybe there is enough world knowledge. So you use language models and maybe some hybrid approaches to find it. Okay. And finally, another area is how to explain your solution. Okay. At this stage, are there any questions about planning and the different areas? Okay. If there are none, one thing which is very unique to this domain or to this problem area is if the model or a formal description of the planning problem is given, you can actually verify the plan, okay, whether someone is giving you the right plan or not. And there are tools which actually can validate them, okay, and that's a very important thing. So your plans can be checked. If your PDL or such a formal descriptions are there, you can check them for correctness. Okay. All right. So that was all about the planning. Now I want to switch towards LLM. Okay. So I'm going to assume that everyone knows about LLMs, but just in terms of the different terminology, on large set of data, there are multiple tasks on which you try to train a language model. A language model is a model which can generate output. Okay. Even a random number generator is a language model, not a good one. And you have the model, right? And you can then use it on other tasks, including the tasks that you trained on, but also other tasks. Okay. And one more thing which you can do is, as part of the training, if you have gotten a model, you can use your own data to fine tune it or improve the model for your own specific tasks. Okay. So these are some of the common terminologies which are used. And then, so LLMs have been used, language models have been around for a long, long time. Large language models have been also around. ChatGPT actually made them very popular. In the AI area itself, researchers are looking at how to use LLMs to improve the AI process. It can be done as part of the data preparation, as part of the AI, whatever the solving is, and also in terms of the result, doing post-processing of it, okay, or setting a baseline. So these are all the three areas where people are using it, and that's also happening in planning. So why explore LLMs for planning? That's because they have demonstrated themselves as good sources of world knowledge, also as hypothesis generator. They've also been shown to be very good language translators. Okay, so what can we do based on this? Is there a pressing need for LLMs? Maybe, maybe not. But people are simply exploring it right now. So the typical way people have been using LLMs for planning is they had the models and which were for general language, and they said, okay, let's put it for planning problems. So that was what text-based foundation models or language models were there. Then about 2 years back, people started fine-tuning it, including something we have been doing in our own group. And we have a fine-tuned model called Transformer. And the new thing which we are pushing for is actually to train language models for planning like tasks from the ground up. Okay, so that I will talk about that a little bit later. So this is a small history of exploration of foundation models for planning. Okay, so there are different views. One of them is that can LLMs actually help in planning, and which is a form of reasoning. And one school of thought says that, okay, they are very poor in reasoning. And with new language models, when they come out, there is another experiment which happens. And that's the kind of work which is happening. The second school of thought is that they are not good reasoners, but or they can be good reasoners, but under limited conditions. So it begets the question, what is reasoning? And to the extent it is just model checking, probably they can be done. And so using fine tuning, maybe using some code-based models. Our example of Transformer, we got very good results. And so that's another school of thought. But everyone agrees that LM-based reasoning may be useful and we need to do more exploration. Okay, so it's a really exploratory thing people are doing right now. So I mentioned about Transformer. This is work jointly with collaborators at IBM at other universities. What we have done is we used Code T5. And so Code T5 means the T5, and code means that it was actually trained on a lot of programming code like artifacts. And on that, we did fine tuning using the planning problems from international planning competitions. And once we have that, we can validate the model. We can do two kind of model validation. One is language specific validation, because these are language models. So that is what your Blue and Rogel and so on are. And the other one is we can actually do plan-based validation, because I told you about the plan validators which are available in this domain. So that is the second kind of validation. And we have shown that under various conditions, this transformer can actually do quite well, solving 90-95% up to that number of problems. Okay. We also did a review of a lot of papers which are coming up in this area. And broadly, the work which is happening, it is under 8 categories. One is, of course, plan generation, but it is also in model construction. Model construction means formulating the planning problem in a formal way from natural language, perhaps, or the representations. There are also in trying to find heuristic functions in terms of integrating with other tools to improve the learning problem, the reasoning problem, and so on. Okay, so you can find more details about this, and hundreds of papers are getting written, and almost about 50 papers per 6 months in this area, we have found. Okay, so there is, as I mentioned, a lot of interest. And what we also noticed was new communities were rediscovering planning. So for example, NLP community was rediscovering planning like concepts. Similarly, machine learning community was learning planning, and so on. And that's because, so for example, machine learning community, it was so much focused on data-driven reasoning. So without data, what will you do? And this is the problem which planning tries to solve. So they were discovering some of the concepts from planning. And similarly, NLP was also discovering like travel planning. So before I go to that, I want to just tell you in plan generation, what is some of the best results right now today? OpenAI's O1 model came out. I'm sure most of you are aware of that. If not, let me know. So in this case, there are a few papers which have evaluated O1 on planning. And whereas previous models, which you see on the upper right-hand side, the best results were in zero-shot setup in blocks world was with Llama. And if you would obfuscate the name of the domains, the blocks and everything, the performance would go to less than 5%. And this was with GPT models. With O1, the performances have actually indeed increased, okay, and to about 97% and 40% and such kind of situations, okay. So 97 up to 97% when in blocks world, but if the names are removed or they are obfuscated, which they call mystery domain, mystery blocks world, it falls to 41%. So there is a lot of memorization of concepts from the data, from the training data that's going on. There's not enough generalization. And what the authors here, these are not the authors of O1, but an evaluation paper. What they did was they randomized the objects themselves and created new problems. And they found that indeed it actually goes further down. So there is increase in performance, but that is from retrieval of or approximate retrieval of old cases. It is still not known what exactly O1 is doing, but there is speculation. And one of the speculation is that it is actually doing chain of thought reasoning under various setups because the data is all around available. And at runtime, it is picking up the instant at instance time, it is actually doing prompt specific rollout of the COT. Okay. Again, these are all speculations because there is no published paper on this. There are other work which have evaluated it on a whole range of other domains. And what they have found is that indeed O1 is better than other models, but along only certain dimensions, not every dimension. Okay. O1 also raises some very interesting implications. One of them is, so if you're doing reasoning, you should not be given all solvable problems. You should be given unsolvable problems. And what do you do with them? Okay. So on unsolvable problems, what these authors found was that it was giving a lot of false negative and false positive answer, which means that you are either cooking up answer or you are not reporting the answer, right? So false, sorry, true negative and false negative, right? So these are the rates which are out here for unsolvable problems. The other thing is the cost of computation. So the cost of computation was in cents for 100 tokens. With the GPT models, O1 especially, it says that I'm doing thinking or I'm trying to call the multiple reasoning rounds. And it doesn't actually tell you how many times, and it may actually blow up your cost. So the same 100 instances, it's taking about $42. Okay, so orders of magnitude more, and what are you getting for it? So that's the question. And I should mention here that in all these cases, Fast Forward, which is one of the planners which I mentioned here, it is a search-based planner and it can find the solutions within second, right? For the largest of the 600 problems that they considered and with 100% solvability. So what is it that LLMs are actually adding, and you're paying more money, more time, and what are you getting? Okay. So that is where the situation is. And I want to pause here, see if there are any questions. We covered planning and the LM side of thing, and then I will move into what some of the ideas we are doing, pushing. Any questions at this time?
Professor, you said you also creating LLM from scratch. Are you going to cover in the future slides or?
Yeah, that's going to be my next thing.
Oh, awesome.
Okay. Any other question, comment, or everything is clear? Okay. So I'm going to talk about two ideas. One is of creating planning based foundation model. Okay. And the second one is using any of these LM planners, so to say, as a S1 solver. And I'll explain what does S1 solver mean, but in a cognitive multi-agent cognitive architecture. Okay. Where they act as fast solvers. Okay. So the motivation here is that many disciplines in computation, they are solving problems which are what we will call planning like tasks. And they are like workflows, programs generation, dialogue generation, and I'll show an example very soon. Okay. And given this, it is already known in many other areas that if you start with generic models, you don't get that good of performance. If you do fine tuning, you get better performance. And if you train your own model using your own data and tokenization strategy and loss function and so on, you get the best performance. So why can't we do that for planning? Okay. So first, I want to convince you that there is a lot of commonality, and it is not about just planning, but a lot of other domains which actually have such similarity. So what we are looking for is the ability to take a sequence of decisions. Okay, and this is like control flow. So we are looking for constructs or areas where control flow is actually created. So this is in business processes, in design diagrams, in something called guidelines, instructions, cooking instructions, plans, web services, workflows, programs, as I mentioned. Okay. In planning, of course, there is a formal state representation. There is data flow representation in some of the other areas. Okay. And then there is also some amount of automatic generation, like in dialogues systems. And there is a paper which actually goes into more of the detail of this. There are some very specific things as well. So for example, workflows have this notion of failures and compensation, okay, which need to be recorded. But long story short, they all bear a lot of similarity, especially with respect to control flow. So now let me show you by a simple example, travel planning. So travel planning is if you're trying to go to New York, you are calling up an agent or you're trying to make this workflow, trying to do your flight reservation, hotel reservation, and maybe ground reservation. Now, there are two instances of this problem, two types of problems. One is called a closed world, where all the services are known ahead of time. Open world, where there might be a new flight which has come up, a new disruption, right? And you need to account for that, even after you have booked. So this kind of problem has been studied for over 2 decades, and I'm just showing you one reference, which of a paper we had, okay? And business process community has actually come up with ways of specifying this in a variety of languages. So either both you can specify it and you can adapt it over new environment, or you can just come up with this. Most recently in the NLP community, they are trying to do travel planning with LLMs, okay? And they are, when the ChatGPT came last year early, they said travel planning is a solved problem. ChatGPT can generate it. And then there were all these guidebooks which came out on Amazon, and they were all nonsensical because people found out that they actually were hallucinating and not giving good 1 day schedule or 3 day schedules and so on. And now in the beginning of the year, we actually have a new, towards the end of the last year or beginning of this year, a new benchmark in the NLP domain in the community, which is on trying to do travel planning. So either it is a solved problem or it's a not a solved problem, right? And the reason it's not a solved problem is because you have to do a lot of reasoning about failures, about your plans, and so on, control flow, which is not expressed in just text. Okay, so this is a quick summary of what are the things which we think are needed as part of a new language model. Okay, and some of this is not very surprising, but I think the specific detail might be. So the first thing is in the data preparation, there are some plan-specific data cleaning which needs to be done. Further, the planning is a multimodal domain. Okay, the way I talked to you, it was all text, but if you think about a recipe, which is a way of cooking food, it is a multimodal representation. Okay, and there's a need for semantic annotation. Then the tokenization design. If you have aware about BERT and other models, they are about next token prediction or missing masking and missing word prediction. That is not how the plans are with the causality and the data flows and so on. We need more. Then, of course, the model architecture, there are some things which are with the state-based representation, which can be considered. There is a need for solving these on the edge. So there is a need for model compression, okay, and distillation. In terms of trust and reliability, so why a specific token is being actually predicted and so on. We have been doing some work on, which is not specific to here, but on rating language models and AI systems in a black box setting. We want to provide that support here. And then there are, of course, the model evaluation, which will be specific to planning also. And then the downstream application. Now, typical downstream application of language models would be like sentiment finding, right? Here, we want to do something better. So there are a few planning specific downstream applications like plan summarization. So this is another idea, or policy summarization. If I have different ways of going to the airport, can you summarize that for me? Okay. And then predicting the plan validity as well as the likely error. Okay. So we can train on these or we can consider them as our downstream applications. Okay. So here are some of the things which we have been trying to do. And there are more tasks which are specific to the planning foundation model. And they are just expressed here. So for example, conditional branch prediction and so on. Okay. So along with this, we also need, we believe that we need to have good information about knowledge, planning knowledge, the language model has to be aware of. So for this, we actually have developed a ontology, a planning ontology, and the paper and the references are here. So what it actually captures is 4 specific kinds of information. One is the problem information, right, which is the problem here. Second is the domain. So I talked to you about the domain like a class of blocks, world problem, or travel domains. Problem is a specific problem. Then planner characteristic, the solver, what it is doing, and the plan that is getting generated. So the metadata around all the 4 of them, we want to organize. And this is what the ontology has. So it has relationship between an explanation of a plan, what does a plan mean, and its relationship with the state, with the kind of actions, the macro actions, if some condition is not there. So what is the relationship? So we have tried to formalize that. And once we have that, we can actually use that in our training process. So that is all I wanted to talk to you about a new language model, right? Focused on planning. Now I want to talk about how a language model, no matter how it is created, how can it be used for better planners? Any questions at this stage?
No.
Okay. So I will now talk about how do we actually do this. So what we have is a planner based on a language model. So it is unreliable. It generates a plan very quickly, but it can actually make mistakes, right? So how can we use this to make reliable planners? So for that, we are appealing to a multi-agent architecture, which was proposed by Daniel Kahneman from a cognitive science point of view, which he called thinking fast and slow, where there are fast solvers, which are fast, as the name suggests, they're subconscious, automatic, and then there are slow solvers, which are more applicable for complex decision making, and they're deliberative. So think about driving. When you are on a new route, okay, you think about the path, you are very careful, and you are actually taking a purposeful decision. Now, as you are traveling and you have been traveling on that route a lot, it is instinctively you are actually taking a path, you are doing a bunch of things, and that is what your involuntary system 1 is. Okay, so both system 1 and system 2 are kind of principles or way of decision making that cognitive scientists have in that community they have studied. So what we have been trying to do as part of another work with the colleagues is, can we actually bring that into a computer model? So this is something which we are calling a SOFI model, okay, or a SOFI architecture, where a problem instance is given. There are fast solvers, there are slow solvers, okay, and there is a metacognition which decides how I should be using the solver. The fast solver tries to give you an answer. You may or may not want to use it. So that is what the metacognition decides. And if necessary, it will call the slow solver. Okay. And so that's the general idea. And what we have shown is, in this kind of a setup, the plans former, the fine-tuned model I was telling you about, we can consider that as a S1 solver. And the search-based planners, we can call them as S2 solvers. So once we have that, we actually have run various problems. And this is an example in, I think this is 6 domains. And what you notice here is time comparison and correctness comparison. It just turns out that FD, which is the S2 solver, is the fast downward, the same solver which was in the O1 charts, okay, the same planner. And what we notice is, as the number of instances are increasing, the S2 solver performance is stable, but then there is a big gap and it starts taking too much time also for hard problems. What a SOFI strategy does is, on an average, we solve problems faster and we are also correct. right? In an average setup. So this is what a more like a human-like reasoning is. So in itself, the solver may not be capable, but a hybrid solver can actually do much better.
We will ask some questions.
Yes.
If I, to the extent I understand, a human brain or a human body would, when there is a perceptual problem or what you call S1 problem, some sensory information comes in, and I think it gets it to me. It looks like it gets processed through a perceptual system, such as you see something and your brain analyzes it, and something goes on. There is no uh, likely role of something like metacognition as a saying should that be done through S1 or S2. On some problem there may be, but there are many issues that we do on daily life that where you may get to S2 but only after doing the S1, and there is no deliberate metacognition that I see happening. The but if you guys have different assumption and different reasons, I would be interested in knowing that.
Right. So we even consider the metacognition at two types. Okay. I think I will give you the intuition here rather than the detail, but it is in one of our papers. The main thing here is that the S1 result is involuntary. You get that anyway. Okay.
Okay.
Now, you don't have to spend time. It's the architecture is such that you get the result anyway, right? So think about
So
if you have the simplest S1 is like a case is your memory. Okay. It may start with no episode, but as soon as you have been driving on a particular path, right, that experience is already there. Okay. You may or may not use it. So,
yeah.
so that was one. Now the
So
metacognition.
you're not necessarily waiting for metacognition to work before S1. S1 is done just as I would have guessed.
Yeah.
It will be done anyway. Okay, that's good. I think that's what I need to know there. The second
Yeah.
question I have is you have these 700 plans available, the ones that you do that. Is that something in your community available for people to use?
Yeah. The international planning competition has the data sets, and definitely, yes, it is available.
Interesting. And are there some plans which here you show, ones that are, one that involve S2 and others don't that involve S2. So are there plans that are categorized? There's the ones that are more complex and requires S1 and S2 to kind of work on. Is that some, uh, is
So,
that kind of classification already developed, or
so in
when you
Mhm, mhm.
go ahead?
So that is indirect answer. Okay. So across domains. So within a domain, it's easier because I know that blocks world problems of say 20 blocks is more they're more complicated than 5 blocks, right? But across blocks or across domains, it's a little tricky. But people have characterized that based on search space complexity. So
Okay.
the short answer is yes.
And
Yeah.
as they have done that, and as you already showed, part that I would have most interest in is that use of knowledge. Is there some clarity on the planning tasks that are knowledge light and knowledge heavy?
Not really. Actually, this is something which um, I, it is not well appreciated in the community. So the role of knowledge in planning has not been appreciated that much. I mean, I should not say appreciated. It's underexplored. People have not considered that.
Good.
The focus has been on search, not on knowledge representation that much.
Okay. So that is an opportunity, right?
Yes, absolutely. Okay, I'll take a few minutes just to kind of conclude. So I started by showing you this planning life cycle where I wanted to tell you that, look, it is the planner is just a component for generation. There are many other activities which are there, which can be done, right? including using your external sources like the domains, IPC domains, planning competition domains, process workflows that you might know, what you have stored, what you have done in the past, right? Your experience. And you can use this not only to, sometimes you don't have to ask the planner to give you the solution, you can just get it directly from your history. And you can use it in formulating the problems and improving even the planner itself. Okay, so as I mentioned, planning is a major subfield of AI, right? LMs are actively being explored. The traditional roles of LMs are in knowledge, as a knowledge source, as a format translator, as a hypothesis generator. All of them are being used. The people are exploring new roles, right? And I try to touch upon that. And our idea is to create new FMs, right, for planning like tasks, as well as bridging the gap between planning and languages. So there are, for AAI 2025 is a major conference in this area. So we are part of two bridge programs. One is to bridge a gap between foundation models and, the natural languages and planning. The second one is between cognitive science and symbolic AI, which I just mentioned to you. Okay. And here are some references, and I can take any final questions or anything you may have.
Yeah, please.
I was interested in your comment about the compression for edge devices, and what do you envision as those possible applications for edge devices?
Okay, so thank you for the question. So the simplest example I can think about is having dialogue generation in applications around us. So think about like toys, okay, in medical device as medicine reminders. So not everyone has phones and not everyone needs phone, right? So for example, children don't need phone, but they need to be told, right? Or there might be very learning opportunities and so on when children are playing with the toys. Okay, so what we can do is we can and the dialogues are nothing but plans, right? So we can actually have compact models very specific to whatever the application might be, right? And with a very low footprint. So that's just an example of dialogue, but we can also be doing the code generation, fixing of issues. Okay, we actually wrote a paper on some of the gaps and how on the edge the role of the language model can be. So I'm happy to share that. So I should mention one more thing is maintenance. So a lot of repairs, okay, happen in remote parts of the world. If you have um, kitchen or a workplace mechanic, automotive failure, right, in the middle of nowhere. So repair guidance is another use case where AI and plans on the edge can be very helpful.
Thank you very much, Biplav. I think it's well in time, well informative, and looks like folks were engaged.
Yeah. Thank you, Amit.
Thank you.
Thanks,
Talk
everyone.
to you at 3:30. Bye.